I'm Professor Leilani Battle. I'm actually fairly new here in the department. This is my second year at Maryland, so I'm not the new kid on the block anymore. But before this, I was doing a postdoc at the University of Washington. Before that, I was back on the East Coast doing my PhD at MIT. And before that, I was actually on the West Coast getting my undergraduate degree. So from this, I'm sure astute listeners can tell that I've done a lot of coast-to-coast traveling. If you want tips, let me know. But I don't really recommend it if you can avoid it. And my research is at the intersection of data management or databases, visualization, and human-computer interaction. So this sounds kind of crazy. Whoa, 3 areas. Why on earth would you do that? It's hard to just wrap your head around one. Turns out, so this area, you might have heard of interactive analysis or human-centered analytics or human-in-the-loop analytics. Depending on what area you're talking to, they'll use these different terms. So for example, there's the Human-in-the-Loop Data Analytics Workshop that's co-located with a major conference in databases, SIGMOD. There's the DSIA, or Data Systems for Interactive Analysis Workshop, which is co-located with Viz. Turns out this year I am co-organizing both of them because they're pretty much the same thing. So motivating this research, why on earth study this intersection? Why doesn't just databases cover it? Why doesn't just Viz or human-computer interaction cover this space? Well, I'm sure it doesn't take a whole lot of arguing to you that everything is becoming more data-driven. Industry, the sciences, you name it, because we're collecting tons of data from all these different sources, right? Telescopes, satellites, field sensors, mobile devices, medical devices, and I bet everyone in this room can think of at least one thing that I should have been on this slide. But, Leilani, you didn't put blah, blah, blah on this slide. That has actually happened to me a lot in previous talks. But, you know, with all of this data, the first thing you do isn't train a machine learning model. The first thing you do isn't necessarily put it in a database, right? You want to see it. You want to make sure you even have what you want. And then you want to start thinking of ways you want to explore that data and make sense of it. Then you build the machine learning models. And to do that, you need ways of exploring efficiently, where visualizations or intuitive image representations of that data can be really helpful. For example, we use visualizations to extract patterns, identify anomalies in the data, or maybe debug our analysis workflows. If something funky is going on, a visualization can be really helpful to figure that out. But in all of these cases, the way you traditionally interact with huge data sets and the way you traditionally interact with, human or computer interfaces are very different. So this kind of notion of interactivity, the idea that things should be fast, things should be fluid, things should be intuitive with the interface you're working with, don't really naturally come out of things like database research. So how do you actually support scalability and interactivity at the same time? So some years back, I developed a system called Forecache, and then later additions to it, which I refer to as Sculpin, where the idea is that we wanted to support both the scalability and interactivity. So here we have this stylized query where we're looking at satellite imagery. And in this case, we're looking at latitude and longitude position, and we're calculating some kind of snow cover index over this latitude-longitude data. What you can do to support scalability, I am a database researcher, so maybe the first step is throw a database at it, yay! But the whole premise of my research is that this doesn't solve the problem. If this solved the problem, I wouldn't be here talking to you today about why it doesn't solve the problem. So databases are traditionally not designed to support interactivity. For example, the database community doesn't care at all about standard frame rates for interfaces. Who knows what the standard frame rate is for a browser interface? Frames per second, how many? Yes, 60. In terms of providing a response from a database within a single frame, you would have to provide a response in under like 20 milliseconds, less than that for sure. But I was actually emailing a colleague today, and he's like, oh, but you could just wait a couple of seconds, right, to get a result. And I'm just thinking, whoa, no, we can't. Not for the kind of performance experiments I'm doing right now. But we're just talking about we're in totally different universes in database world, database land versus human-computer interaction land. So how actually do you support this? Well, something you can do is, rather than looking at just the database or rather than looking at just the visualization interface, they can talk to one another and you can design optimization layers in between that take advantage of information from both sides. For example, if you have an idea of how users interact with satellite imagery data, you can use that information to try to pre-compute or pre-process or pre-fetch data from the database in anticipation of what you think users are going to do. So the system looks a lot faster than it really is under the hood. All right, but my system obviously isn't going to be the only interactive analysis system that ever exists or will ever exist. And in fact, there are already quite a few different systems out in the world. So as a researcher, you might ask the question of, okay, but which of these is best, and for under what conditions would I prefer one over another? Or you may even have a simpler question of, take two systems, how does one system, like the one I developed, Sculpin, compare to other systems like Tableau or Kyrix or whatever? Actually, with the way that we evaluate these systems right now, it's really, really hard to answer that kind of question because we don't evaluate them consistently or in a standard or standardized way. For example, this class of systems, they evaluate on completely different data sets and tasks. So whatever thing the user wants to do, it just has to be very different across these systems compared to Sculpin. So in that case, if you just look at the numbers from those papers, you'd say, we're comparing apples and oranges, can't really do that, doesn't make sense. In this case, they don't even have performance studies with real people. They may have done some little cute benchmarks and said, oh, look, we're fast. But if you haven't even evaluated with real people, you don't even have data to compare against with what I did, where I actually did run user studies to see how well the system that I developed worked with earth scientists who often use satellite imagery in their own research. Okay, so what do we do to solve this problem? So with the existing research methods or evaluation methods for these systems, we can't really answer this question. So that leads to some of the ongoing research in my lab where we're talking about, okay, how do we standardize this evaluation process for all these kinds of interactive analysis systems? What we really want is a benchmark. And this is actually a really cool example of translating things that are very common and taken for granted in databases, like benchmarking and systematic evaluation, performance evaluation, and kind of teaching or introducing to the HCI and visualization communities how we might be able to do that in those areas as well. So for example, how might we design a benchmark for something like Sculpin? Well, what you want first is a data set generator, because any systems you want to compare, it should be visualizing the same data set at least. Then on top of that, those systems should be supporting the same kinds of interactions. So if I'm driving input from a benchmark, I want that system to be getting the same sequence of interactions, maybe at roughly the same speed, so I can see what queries get generated or other kind of data processing needs to happen to evaluate the performance of that system under those conditions. And then finally, you want to be evaluating under the same kinds of metrics. If I'm using metrics A for this system and metrics B for this other system, how exactly can you directly compare them? They really need to be using the same metrics for comparison. So all of these things together are the nuts and bolts of a benchmark, or at least what you would hope would be a benchmark for interactive analysis systems. And we're actually developing the pretty much first ever interactive analysis benchmark for the database community for a particular class of interfaces called dynamic query interfaces. So here's a video showing you one type of interface called a cross-filter interface, where something that's really interesting here is that even a pixel level change in the filtering that this user's doing on these histograms produces changes in all of the surrounding histograms in this data set. There are a whole bunch of different visualizations. You can interact with any one of them, and even a tiny difference that takes a very, 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 very tiny sliver of time can basically change the entire data set you see on the screen. So things moving this fast, you really need low latency, and you really need to carefully test database systems in a way that they're not used to being tested. All right, but of course, this also has the added assumption that when I say, oh, I'm helping people explore data, and someone else says, oh, I'm also helping people explore data, we're making assumptions about what exploration even means. We're saying as a community, oh yeah, we're saying the same thing. So all these times that you see someone say exploration in a paper, we really mean the exact same thing. Actually, it turns out that's not true. We even wrote a whole paper on this about how when people are saying exploration, they really mean different things. And they mean different things at different times over different subtopics within exploration, et cetera. So for example, in terms of goal formulation, you might say, oh, exploration, it should be really open-ended. There shouldn't be any goals. And we actually saw papers that saw this. But then we saw another case where when people said exploration, they said, oh, no. People have specific goals. They have things they want to achieve. They don't just go into Tableau and say, oh, yeah, let's have some fun, y'all. Let's explore some data. No, they've got like deadlines. They've got a boss that they need to satisfy. They've got like to-dos. They got goals. But if both of these are right, then what the heck does exploration even mean? So even at the basis of terminology or theoretical underpinnings behind all this evaluation stuff, you really need to think hard about what does it mean for us to all be on the same page and do the same kind of evaluations and make things comparable and systematic and standardized. So just zooming out a bit, so I've talked a lot about this benchmarking and performance work, which is more database-oriented. I also look at how we can take something as complicated and opaque as a database system and make it more transparent so that end users can understand what's going on through visual interfaces. I also do a lot of analysis of user behavior and how we interpret user behavior to better understand how to design systems or more effective analysis systems in the future. So my research is generally split between all these different areas pretty evenly. And if you are interested, feel free to reach out to me over email. Got stuff on my website. My lab website's coming online hopefully soon. If you're taking my class, yay. And that's it.